So let's practice using the second fundamental theorem of calculus. If you want to take a picture of these 6 problems and stop the video and record these 6 problems on a piece of notebook paper, and then once they're recorded, come back and we can work them out together. All right, we have 6 problems, all of which are f of x, capital F of x equals an integral with a variable in one of the limit positions, either a or b, either the lower or the upper limit. So the other limit is a constant. So we're asked for all 6 of these problems to follow the same set of instructions. Let's find f prime of x for all 6 of these problems. All right, so for number 1, we want to get down to f prime of x. That's our answer. So let's do this first. Let's come down here, skip a couple of lines. We're looking for f prime of x. So that's going to be our first step, is recording what we want, f prime of x. Now, how do we go from capital F of x to capital F prime of x? Well, we find the derivative. So let's go ahead and show the derivative operator. So step 2 on both sides of this equation is to bring in the derivative operator, d over dx. All right, step 3 is going to be to actually perform those computations. All right, so what we have here is we have the derivative of an integral. We have inverse operations. We could go through, like on a previous video, find the antiderivative, evaluate it at the limits of integration, and then only turn around to find the derivative. Well, that shortcut that we saw in that previous video, okay, required that we did a few things. So the first thing to get our answer for capital F prime of x is to do this. Notice the limits of integration. Is your constant limit of integration in the lower limit position? So yes, it is here. If it wasn't, I would have to include a negative in my answer down here. Step 1 for the shortcut is to make sure your limits are behaving properly and your constant limit of integration is down here. Second step, go to the other limit of integration, the one with the variable, and find the derivative of that limit of integration with respect to x. So the derivative of 3x minus 5 is 3. We're going to take 3 and we're going to multiply it by the third and final step that we do in computing this answer using the shortcut. We found the derivative of the variable limit of integration. Next thing we would end up doing is we're going to replace this t with this limit of integration. So I might go ahead and put another parenthesis here, and wherever I see t, I'll replace it with 3x minus 5. And don't forget your plus 2. Other than a cleanup, we're finished. So cleaning up, cap f prime of x is equal to 3 times, and I'm going to come in parentheses, clean up, and get 3x minus 3. You could distribute that 3 if you wanted to and get 9x minus 9, but that's not really a part of the cleanup, unless you want it to be, in which case it's a correct answer as well. All right, look at number 2. Let's find cap f prime of x. Step 1, write down what we're finding. Step 2, bring in the 2 derivative operators. So step 1, 2. Step 3 will be to compute the answer, okay? Instead of integrating and evaluating to turn around and differentiate, let's do 3 things in our attempt to get the answer. First of all, notice the limits of integration. They're not behaving properly. This 7 should be down here and the 5x squared should be up here. So the first thing I notice is that's going to require a negative as part of my answer. That's kind of a long negative. Second step, find the derivative of the variable limit of integration. So that's 10x, and it's always going to be times. Third and final step, everywhere you see t, replace it with 5x squared. So for this t, I'm going to replace with 5x squared. Now I'm going to reach inside these parentheses, but I'm going to change that parenthesis to a bracket because right here where I see t squared, I'm going to use these parentheses for my t, or my 5x squared, and I just didn't want another set of parentheses. So right here where t is, I will replace it with 5x squared. Okay, a little bit of cleanup. I'm going to go ahead and multiply these two factors together, getting negative 50x cubed. I'll go ahead and change back to a parenthesis. When I square this, I'm going to get 25x to the fourth plus 1, close your parenthesis. You don't have to distribute negative 50x cubed in. It'd be fine if you did. Okay, number 3. First step, second step, third step is going to be the answer. Limits are good, constants down here, variables up here, derivative of the variable limit is 1. Final step, everywhere you see t in the integrand, replace it with x. Some might ask, is it necessary to put the 1 there? No, but it's just a visual that you did go ahead and take that step of finding the derivative. It just happens to be 1. Doesn't matter. Example 4. If you feel comfortable, stop the video, complete these 3, and then turn it back on and make sure you have all the right answers. Or that I didn't make a mistake. Very possible. Limits are good. Derivative here. Put a multiplication. In the integrand, I see t here. I'll replace it with x squared. There's really no cleanup on that, but I do want to show you a different way to write that. This square on secant could be pulled off and on the outside of the secant function. So if you took this square off that secant function, you'd have secant x squared inside here. Just wanted to remind you about that. This answer's fine. This is fine too. Hope you're trying these on your own and coming back and checking your work. 5. Limits are good, don't need a negative. Derivative of square root of x. Remembering that square root of x is x to the 1/2 and using the power rule. And the integrand is t to the 4th, so everywhere you see t, I'm making a parenthesis, put the 4 power on the outside, I'm going to put in square root of x. Clean up. I notice I have a negative exponent and 2's in the denominator of a fraction. So I'm going to go ahead and just create one big fraction here. So I'll have 2 in the denominator. I'll have square root of x in the denominator. And I just want to go ahead and simplify this. Well, square root of x to the 4th power would be x squared. And of course we know we can't divide out this x under the radical with one of these, so we're done. Limits are good, don't need a negative. Derivative of 2x cubed is 6x squared times, I have 2 t's here, so I'm going to replace 2x cubed in for both these t's. And it might be kind of good to put parentheses around here. It kind of clarifies everything. There's no cleanup. Of course, we could not multiply 6x squared into either one of these. That would be your final answer. Just a reminder that when you do differentiate an integral, the integral disappears, but the dt goes away with it because those two operations, they come on together and they leave together. All right, so hopefully this was a good reminder of the other video notes that you watched and how to find a derivative of an integral.